Hello and welcome. It's been quite a while since I recorded my last WebGPU video. I ran into a bit of a snag with texturing, and I'm sure you understand it's very demotivating to sort of sit there for several days working on a problem and make no progress and feel that it's, anyway. But good news is I've worked it out with help from, thanks go to Michelangelo Webb and Chase Moscal. Thank you for your suggestions. It worked. I got it working. So what is the issue with WebGPU? Well, the issue is if we grab a texture, go into this image folder, we have this le chat noir. If we grab this image, we are sort of looking within a file structure, and there are reasons that you would not want to do that. That's a security risk. Now, there is a workaround, and the workaround is essentially we don't browse into our file structure. What we do is, let me just build this up. I should have built this ahead of time. Well, let's build it now. Okay, so in here we have this distribution folder, and this distribution folder is basically the resources that a file server or a web server will have access to when everything is hosted. So what I'm doing is I'll just put the image inside there, and then we'll fetch it from there, and that'll get around the issue. That'll fix it. There is one more thing, and that is, at the moment, I'm using, where are we? HTTP server. HTTP server is not very good. I mean, whatever, it's probably fine, but it's not working here. So what we can do instead is I'm using something called LiveServer. So we can go npm install LiveServer global. Now, the issue why LiveServer works and HTTP server doesn't work. Well, if I knew why, it probably wouldn't be. They'd probably be working, right? Okay. Well, the issue is when I serve the site on HTTP server, it doesn't update the files properly. I can make an edit to the TypeScript, transpile it, and then it won't load. And I've tried a few things. I tried messing with the cache settings so that it sort of forces it to reload each time. It's not working, and it's not worth my trouble, so I'm just going to go with LiveServer. Okay, now it says we should write npm audit fix, just to fix any issues. That seems fine, and now we can go ahead and use that. So down here in the serve, we will run LiveServer, and I'm going to allow cross-origin resource sharing. So this lets us fetch those image files from our server directory. Now, all we need to do is go npm start, and it starts everything up. By default, LiveServer opens up in Google Chrome. So of course this isn't going to work, but we can just grab that local host, that web address, and paste that into Chrome Canary, and that is working. We can Control-Shift-I. That's favorite icon. That's fine. No worries. Okay, cool. So finally, let's get into this and get it working for the texture. So we'll leave the triangle there for now. I'm not going to modify that. What I will do is I will make a material and load the class, load the image. Just check that that's working. So we can go new file. Oh, we have it here, material.ts. Okay, there we are. I must have made this ahead of time. Okay. So we have this material The material is going to have three objects which are really important. It's going to have a texture. Okay. It's going to have a texture view. And it's going to have a sampler. Now I might adjust this in future so that I'm not having a single sampler for every texture, because actually the sampler, we might be able to get away with just making one. Who knows? We'll find out. I think we can. Now, yeah, so we have texture, and then a texture view is sort of a protocol for accessing the texture. And so when we do drawing stuff, we always work with the texture view. But for now, we're going to have to work with all of it. So we'll have an initialize function, which is asynchronous. And this is going to take a device. And we're going to need a URL to point to the thing that we are loading. Okay, so I'm going to break this down into a number of steps. We're going to have a load image. Let me just actually I just realized we don't need that. Yeah, let's not do that. This is a bit of jazz. I'm just looking at my notes from previous videos and realizing some of this is redundant. Okay, so let's get into this. First thing we want to do is we want to fetch the image that corresponds to the given URL. So we're going to do a URL fetch, which will return a response. And then we're going to do a bit of massaging. We're going to change these data types. So we're going to get this into a binary format. And chunks of binary data are called blobs. So we're going to go get that response and get a blob from it. And then we are going to get an image bitmap from that blob. So we'll say this is an image bitmap type. Create image bitmap on that blob. Okay, so this sort of fetches the raw data for the corresponding URL. And you know what? Let's just sort of set this up and call it and see if it doesn't throw an error. So we'll go to our renderer, and then down here we have a triangle mesh. Let's go material, and we are importing that, and material is exporting. Yeah, good. Okay. So then we can go down to, come on, create assets. Okay. We'll say okay, so that creates the class, and then we need to initialize it. We're going to pass in our device and the file path to the image. Okay, let's just, oh, what's going on here? Oh, yeah, okay. So this will have to be an asynchronous function. All right, fair enough. So let's run this and see if it makes any errors. We'll just go new terminal, and then, so every time I want to restart it, I'll just go npm start. It's a little bit annoying. I'll try to not do it unless we have to. Reload that, Control-Shift-I, no errors. Even the favorite icon thing has gone. So yeah, that's awesome. Let's keep going. And let's get the rest of this. Yep, good, okay. I'm not spawning a whole bunch of servers in the background. Okay, so back to the material. So this function is essentially going to take that set of raw data, and it's going to make a texture and send the data to that texture. Okay, in order to do that, we are going to need a texture descriptor. A texture descriptor has a number of flags which we need to set in there. We need to declare the size of what we're making, the pixel format, and how it's going to be used. Okay, so the size is itself a structure. The size has a width and a height. And for both of those, we can query the image data. Okay, now for format, let's just hard code this. It is RGB. There we go. Now, usage. We go GPU, texture usage, and there's a bunch of these. So we want it to be a, where are we? Texture binding. As well as that, we want it to be a copy destination because we want to copy to it. And it turns out WebGPUs, sometimes it'll complain and say we need to set it as a render attachment. Okay, I mean, I'm not going to use it as a render attachment, but I guess we need to specify that it could be used. Look, the spec is the spec. Okay, so now let's create the texture. So we'll say this texture equals, we'll go create texture and throw in the texture descriptor. Okay, now what we need to do is we need to copy this image data onto the texture that we just created. So this is work. Copying data is work, so it's performed by a device on that device's queue. So we'll say get the device's queue and copy external image to texture. Now here we have a source, destination, and a copy size. And yeah, that's what we're going to work with. So for the source, we go, source is the image data. And a lot of this working out of where curly braces need to go and all of that is sort of done by trial and error and Googling. Okay, so source, image data, texture, there we have it. That's the texture that we're copying to. And then for the size, we go texture descriptor size. And that, yeah, that is it. Okay, so again, where are we? Let's call this. So we'll go await this. Okay, then we'll just go through the process of checking that, checking it doesn't throw any errors. It sometimes does. There we have it. That's looking good. And no errors. Okay. Cool. So onwards. So like I said, there are 3 structures which we're sort of dealing with. So now we've loaded and created that. Now we're going to make a texture view. And for that, like most resources, we'll start by creating a view descriptor. Okay, so there are a number of properties we can set. And a lot of this is just the same again, but yeah, it is what it is. Okay, so we have dimension is going to be, we see here we have all these options. Let's go with 2D. Aspect is describing which parts of the image do we want to view. We're just going to go all. So that's the red, green, blue, alpha. Base MIP level. Now we actually don't need to set these, but I like to set them anyway. They have default values. The default value is pretty much what I'm putting in here, but I find that it looks nice. Base array layer. Okay, so now we can create this. So we say this view equals, and this is a funny thing. We create the view based on the texture. So we take our texture and then we call create view on that. Now we're going to create the sampler. So similarly, we'll make a descriptor and we'll just configure this. So what would we do? This is pretty similar to making a texture in OpenGL. You specify the repeat mode, the minifying filter, magnifying filter, all of those properties. And what we can do is we can sort of create those, make a sampler object, and now the sampler objects are actually independent of the textures, although I'm not using them that way in this video, but they could be. So address mode U will be repeat. We can see that here. The default, by the way, I think is clamp to edge. Address mode V is repeat. Now there's a W address mode as well, but we're not doing three-dimensional textures, we're just doing two-dimensional. So then the minifying and magnifying filter, I usually go linear for magnifying, stretching things up. And for minifying, I don't think it matters. I usually go nearest. There are other options. We have what's called a MIP map filter, which is saying sort of how do we determine which MIP level to use. We'll just go nearest. We don't need to set that. We're not doing MIP mapping, but it's just good to see that the option's there. And then max anisotropy. We are not doing anisotropic filtering, multi-sampling basically. We can just put 1. I think that's the default value. That's fine. Okay, so now we can create our sampler. Yeah, create sampler, and we'll pass in the descriptor. Okay, so all of these 3 objects have been created, presumably with the correct settings and everything. So now let's go to the renderer, and I'm just going to step back through the setup here. So if we look at the initialize, we should do this, shouldn't we? Because that's now an asynchronous function. Okay, so we set up the device, then the assets, and then the pipeline. We sort of need to create the assets before we create the pipeline, because certain things, the layouts basically of memory usage and various resources, they need to be specified before we know how we're using them. This is actually, the other day I was looking at OpenGL in Mac, and in Mac, it will throw an error if you compile a shader before you define a vertex array. And this is pretty similar to that, actually. It's also pretty similar to the way it's done in Metal. Okay, but anyway, make pipelines. So the thing is, we need to specify that we are using this sampler and texture in our pipeline. So here we have a bind group layout, and this is a general description of the types of things which will be used, basically. So we can specify a few more of these. At binding 1, we're going to have a resource which is visible in the fragment shader, and that is going to be a texture. And we don't need to specify the texture, we just need to specify that there will be a texture. This is also good to look back on and refer to down below. Okay, so then in binding 2, we're going to have a resource visible to the fragment shader, which is a sampler. Okay, now this has been set up. We can populate our bind group. So the bind group is specifying the actual resources. We would actually have a whole bunch of different bind groups for a whole bunch of resources. Okay, so what do we have? At binding 1, the actual resource which is being bound is, we go material, and then we send the view. So it's the texture view, not the texture. Might be a little confusing. And then another one at binding 2, this material sampler. Okay, now we actually don't need to do anything else. If we look down below, right down below in the render, we set the bind group, index number 0, so group number 0, and we set in this bind group. So this bind group actually includes all of these 3 resources that we just defined. So they all get bound in one call. So this is fine. But then onto the work here. So we do need to change our triangle mesh object because we're not doing red, green, blue anymore. Instead of red, green, blue, let's take texture coordinates U and V. So let's fix this up. Okay, so U is the horizontal. Here we have y equals 0, y equals negative 0.5. Okay, I'm just gonna, okay. Let me just put this in. Okay, so we have 0.5 and then negative 0.5 will be on the left, so this will be the center point. So 0.5, the left side, and then the right side, so 1.0. And then these 2 points have a z of negative 0.5, which means they're on the bottom. And so we'll send in a v coordinate of 1. I know that makes a lot of sense, but it works. Trust me. And we can always experiment and change things around. So we have changed the size of this. So we're going to have to change the array stride as well. We've now got 5 floating point numbers, so a stride of 20 bytes. Shader location 0 is fine. So shader location 1 should be 32 by 2. Offset of 12. Yeah, this is okay. This is looking good. So we are almost done. We are so close. The last thing we need to do is modify our shader. Okay, so we'll go to shaders. And just give me a second. Bring up my notes. Okay, so how are shaders done in OpenGL? Well, we have a sampler 2D. And the sampler 2D is a uniform, so it's applied to everything. In Metal, on the other hand, a sampler is actually defined in the argument list for a function. And we're going to go with, in WGSL, we go with the uniform style approach. So we actually declare our global objects up here. So let's go binding 1, group 0. Okay, so we have a variable, and we're going to call it my texture, and the variable type is texture 2D with data type float 32. By the way, if we're not sure about this, I just had this up before. We have the WebGPU shading language specification. It is a little hard to read. So I sort of looked at this and then I double checked with other snippets of code that I could find online to check that it was working the way I thought it was. But yeah. Okay, so we have that. And then we're going to have our sampler object. So this is binding number 2, my sampler, and this data type will be sampler. Okay, now it's just the bureaucracy of adjusting all of this. So I'm going to call this, instead of color, this will now be called texture coordinate. This will be a vec2. And what we take in here is vertex texture coordinate, and that will be a vec2. And yeah, we're just passing this along. So we take the vertex texture coordinate, do absolutely nothing to it, and pass it along. And then fragment takes in location 0, that texture coordinate. Okay, what we want to do is we want to sample. So the function name for this is texture sample. We take the texture object, the sampler object, and the coordinate. And this should do it. Fingers crossed. Reload it, and there it is. Very nice. Control-Shift-I, and there are no errors. So there we have it. We have got textures working. That's very cool. Yeah, hope you enjoyed that. Hope this is sort of clearing things up, making it more understandable. And yeah, have a good one. Bye.